Hi, everyone. I'm Areias. I'm data scientist at Kineviz. Thanks so much, Neo4j, for the invitation to present today, the opportunity. It's been super interesting. So I'm here today to talk about how we can use Neo4j and GraphXR to analyze 30,000 dream journals. And while the choice of dream journals is a bit tongue-in-cheek, the methods and tools that I'm going to show today, we can use to analyze any large collection of documents. So what's our agenda? We're going to work with dream journal entries from UCSC's DreamBank. We're going to connect similar dreams in a dream similarity graph. We're going to extract named entities to understand what the dreams are about. We're going to use a community detection algorithm to find dream clusters. And we're going to use neural network text-to-image generation to generate dreamy images based on a dream's first sentence. All our dreamer, dreams, and entities we're going to load into Neo4j, and that's where we're going to create the relationships. And we're going to use GraphXR for analysis and visualization. So what is GraphXR? GraphXR is a browser-based graph data analytics and visualization platform. So in the first part of my presentation, I want to show you how we can use GraphXR to analyze and visualize our dream data. And in the second part, I'll walk you through the code that I use to process and upload the data into Neo4j and connect to GraphXR. So first is our dream similarity graph. So I used a GenSim doc2vec model to train dream embeddings based on the dream content. And for every two dreams, I compare them, and if they have a high cosine similarity, I connect them into a k-nearest neighbors graph. So this is our first GraphXR view. This shows the dreams for UCSC women. So some of the dream journals are penned by individuals and some are by collectives, like UCSC women. So this shows which dreams UCSC women have in common with the other dreamers. So I'm going to click on my screenshots and open up the GraphXR graph space to show you the interactive version of that image. So this is GraphXR, and you can see I'm in my browser, except I'm on full screen. So over here on the left, we have the main menu with the tools at our disposal. On the bottom here, we have a context toolbar. Up on the upper right corner, we have the legends, and we have some navigation tools on the right. So what do we have here? We have 43 dreamer nodes. They're connected to their dreams by the dreamt by relationship. Then we have 340 dreams, and they're connected amongst each other with the most similar relationships, right? So how do I create this image? I can clear the data. Yeah, and then on the project panel, here and with the categories, we have the nodes that are in our Neo4j database connected to our GraphXR instance and the relationships. So I can pool some dreamers. And let's choose Jasmine 3. I haven't done her yet. Let's close this panel. Oops. I'm going to inverse my selection and delete. So now I'm left with only Jasmine 3. I'm going to expand on her dreamt by relationship to pull up all the dreams that Jasmine 3 has dreamt. Yeah. So now we have 259 dreams. Yes. Select those dreams. I hit expand again. I'm going to pull up the most similar dreams. So these are based on the embeddings. Expanding. Oops. Turns out Jasmine 3 has a lot of the dreams. So let's just work with 528. Now I'm going to select those dreams and expand dreamt by. Because now I want to know who dreamt these dreams that are most similar to Jasmine's 3 dreams. But what we have here is a bit of a hairball. So I'm going to select our dreamers. I'm going to go to the layout panel and choose rings. So this makes my dreams array themselves around my dreamers. Oh, so this is an interesting case because Jasmine 3 just so happens to have several dream journal sequences in different periods of time in her life. Jasmine 1, Jasmine 4, and Jasmine 2 are all Jasmine. Yeah, so this was the risk of picking a dreamer I hadn't worked with before. Well, in any case, what we can also do, so this most similar relationship actually has a weight property, the similarity score. So I can filter by that. It's an edge property, similarity. So the most similar edges here range from 0.6 to 0.94 in similarity score. So what I can do here is say, well, show me only those with at least 0.75 in similarity score. And that actually kind of removed most are, let's see, 65. Then we're still left with a couple. Okay, so that's our first view. Let's go back to the presentation. Now I want to show you how we are interpreting what dreams are about using spaCy. spaCy allows us to extract named entities from the dream text, so mentions of people, places, things, and other categories. And this way we can have a high-level view of what a dream is about, or even a dream cluster. So this is another GraphXR view, and by chance this is also Jasmine 4's dreams. So today we're going to learn a lot about Jasmine 4. Loading the GraphXR graph space. Okay, so what do I have here? I have 94 dreams arrayed in a circle, all of Jasmine's 4 dreams. And let me get that out of the way. The dreams have a property number, which is essentially the order the dream was dreamt in. So I can actually color by that property. And we can see that I've arrayed the dreams in temporal order. So they're going counterclockwise here. The earlier dreams in the dream journal sequence are lighter color and then darker color for the later dreams. So that's the dream. Now I want to show you entities. So entities, there are several different types of entities. And those are the ones that we extracted with spaCy, right? To get an idea of what are these dreams about. So the most frequent entity extracted is that of person. So now I've highlighted the person entity nodes. And you can see that there are different sizes because I've actually, for every entity node, I used the algorithm panel and I've calculated their centrality degree. So that basically creates for every node a new property called GXR degree that shows me that this node is connected to 10 dreams. And I can set that property to size the node. See, so if I unclick this, all the entity nodes now have the same size. I can set the size, and now we can see it's just easier to see which people are most frequently mentioned in Jasmine's dreams. Now let's take a look at Sam, for example. So if I use Sam is a pretty big deal given the size of his node. And if I use the trace neighbor tool up to one neighbor, we can see highlighted the dreams that Sam is mentioned in. So we can see that Jasmine, at this beginning of her dream sequence, Sam is a frequent dream topic. Then not so much, and then he's just more dispersed across time. So this was a deep dive into Jasmine 4 dreams. Back to presentation. Now I want to show you how we use community detection to form dream clusters, and then also how we use the neural network to generate a dream snapshot from the dream content. So this is one cluster related to sports, and when we hover over a dream node, we're going to see the dream snapshots that the LF2 image neural network generated. Okay, so this is one cluster, and I'm about to show you how we form these clusters. Here we have 18 dreams and 18 entities. And given that the entities are Fenway Park, Johnny Unitas, Tigers, the Detroit Tigers, Baltimore, I've decided that the topic of this is mostly sports. When we hover over a dream node, we get this info panel that I've defined to give me the first sentence of the dream and the image that was generated by the neural network. So here I was waiting to watch or take part in some carnival games. It's a very colorful image of a crowd. It can definitely be a carnival. Let's see up here. I was going to play football with a bunch of guys. So here we definitely see, a football shape in the middle, some guys' faces, some green for a field. Let's see here. I was in a football stadium with my daughter, Christina. This is actually one of my favorite photos. You can definitely see a middle-aged man that probably took Christina, the little girl, to the stadium. So how did we add these photos or these images? Each node, I added a property. Here we go. An image URL property here, where this image is basically hosted in my GitHub account, right? And then using the project panel for each dream, there's this button, Edit Quick Info Template. So the quick info is the thing that comes up when you hover over the node. So I've actually defined two custom functions that render if a node has the property image URL, you can render the image and also the first 100 characters of the dream content. So that's what you see when you hover over the node. So now let's look at generating a cluster. So when I pull dreams from the project panel, they come out 25 at a time, but I can also use a cipher query to pull out more dreams at once. So here's me pulling 1,000 dreams, and they're going to load the inner relationship as well, which in this case is the most similar dream relationship. Okay, let me fly out so we can get a better sense of what we're dealing with. Let me also turn off the quick info panel because we don't need it right now. There we go. So 1,000 dreams, and between them we have 1,213 most similar relationships. So I'm going to select all our dreams, and in our algorithm panel, I'm going to use a community detection algorithm, of which we have several, and I'm just going to choose label propagation. So that means that each node now has a label propagation ID property added to it, and we can call our nodes by this property. This is, for example, the biggest cluster with 173 nodes. 75 nodes for this one, 33, 29. So we can choose to deep dive into one of these clusters. So by selecting this 29, I can inverse my selection down here in the tooltip, delete, and then center to our chosen cluster. And then we can expand this cluster entities and see what this is about. So let's see. We have now 29 dreams and 97 entities. Let's look at the entity types to get a sense of what is this cluster about, right? So 49 are people, cardinals are usually just quantities. I can take this away. Organization, that's probably useful. Money, let's remove those. And then the other ones are not so numerous, so we can remove them just for ease of exposition here. So I'm going to select all entities, calculate their degree centrality so that we know how many dreams they're connected to, and we can size them by that property. Oops, there we go. Now entity types, people. Let's use the layout panel and array them in a circle by property of degree. Great. If I press down 5, there's actually a lot of people in this circle. I can move all selected nodes together. So for example, if I click on Bob and use the trace neighbor up to one neighbor, we can see the dreams that Bob has been mentioned in. And actually I have to remove the most similar relationship for now. Right? And then, so one neighbor out, the dreams Bob has been mentioned in. 2 neighbors out, other people that have been mentioned together with Bob in the same dreams. Oops. Yeah. Well, what else did we have as an entity? I think we only had 2 types of entity nodes in this. Organizations. Well, Bob apparently has not been, let's see, 2 neighbors out. Do we see any yes, organization Mali. So we can see co-occurrences, right? Bob has been mentioned in those dreams, and then who else and what other organizations have been mentioned in the same dreams. Clear this data. Last thing I'm going to show you is that actually you can also save views, right? So oops, nope. I want to load it. Yes. You can save views that you've created. You can load them back, and you can also get a shareable link so that you can share that view with other people. So this is the original view that I showed you with the dream snapshots. So what do we have here? 18 dreams and 18 entities. But who dreamt these dreams? So I'm just going to expand on the dreamt by relationship to get the dreamers. So we now have 8 dreamers. Let's color them yellow so they're more visible. So the way that I've set up the data in Neo4j is that dreams are connected to dreamers and entities are connected to dreams, right? Dreamers are not connected to entities. But what now, if I want to know now, well, what dreamer has dreamt which entity? We can do that with our transform panel and our shortcut. The center category that we want to get rid of is dream. So we want to go directly from dreamt by to has entity. And we're going to call this new relationship dreamer entity. Let's make it directional, run. And now you can see that we've created a new edge that connects dreamers directly to entities. So we can actually just get rid of dreams. Oops. And we're left with just dreamers and entities. And if I use the grid layout just to get some more space between my dreamers, you can see who's been dreaming what. Great. Let's go back to our presentation. Great, and now we come to the second part of the presentation, which is a bunch of code, basically. So this is the original site where we get the DreamBank data. from UC Santa Cruz Psychology Department. But you don't have to scrape it because Matt Bierner already has, and you can just clone his GitHub and download a JSON file for each individual dreamer. So this is what one JSON file looks like: dreamer, description, and the dreams. We're going to put all these separate JSON files into a pandas data frame to work with. Who are our dreamers? So we can see here that the most prolific dreamer with 6,000 entries is actually in German, and there are a couple of them in German. This one's a little creepy. Norman, a child molester. And then we have Ringo with only 16 dreams. So once I clean out the German language dreams, we have 20,000 unchanged dreams and 69 unique dreamers to work with. So the embeddings from the dream content. We use doc2vec and to generate the embeddings, and then we calculate how similar two dreams are by the cosine similarity. What is doc2vec? This is essentially an extension of words2vec. And I'm not entirely sure. Usually when I practice my presentation, I'm running out of time here, so I'm going to direct you to this Medium post on the explanation of doc2vec. We process the data by removing stop words and tokenizing. This is what the first dream looks like once it's been pre-processed, tokenized, and without stop words. And we do the same thing for the entire data frame. Then we feed it into doc2vec model with the default parameters, and we save it for later use. This is what cosine similarity kind of looks like. You have, document vectors in vector space, and the angle, the larger the angle between them, we interpret that to mean that the less similar those two documents are. With this function, we can get here, for the first dream in our data frame of dreams, give me back the 5 most similar dreams. And it gives you the index position of that dream in the data frame and the similarity score. So we can see that the most similar dream to this first dream is actually itself, with a similarity of 0.96. So that's not very helpful. So from now on, we discard the first most similar dream. And the other ones aren't that similar, with similarity scores of 0.5. Let's add to the whole data frame the 9 most similar dreams and look at the distribution of the similarity score so that we can choose the threshold that we decide, well, those two dreams, we should connect them in our graph. So for the first or the second most similar dream, we see that most similarity scores are above 0.6, but they decline quite rapidly, and there's not that many beyond 0.7. Right? For the 9th most similar dream, then most scores are below 0.6. So that's why I chose 0.6 to be this threshold in which I'll connect two dreams that have a similarity score higher than that. Extracting entities with spaCy. So spaCy is a pre-trained model that, given some text, can identify named entities. And that includes people, companies, locations, dates, time, money. There are many categories that if you click on spaCy and go to the documentation, you can see. So we import spaCy for each row of our dream data frame. We're going to extract entities from the dream content, and we're going to append them to this list together with an ID for the dream. I'm going to group by because what happens is the same entity appears several times in one dream, and we don't want to upload them multiple times. So once that's done, we see that the most numerous entity is person, followed by cardinal, which are numbers, and organization. Now we load dreams into a Neo4j database running on Docker. So assuming you have Docker installed, You can use this simple example bash script to spin up a Docker container with the Neo4j database and automatically install APOC and Graph Data Science libraries. Then we can upload the data into Neo4j using Py2Neo. So this is the connection to your local database. First, we create constraints just to make sure that our Dreamer nodes, our Dream nodes, and entity nodes are unique, and this also helps with performance. Creating our Dreamer nodes. So I'm going to create a dictionary of Dreamers and use a unwind cipher syntax with this dictionary. So using Py2Neo, you can feed in the data into the Neo4j database. Creating dream nodes and connecting them to dreamers with the dreamt by relationship. Same idea. We iterate through the rows of the data frame, create a dictionary with the data that we want to put into Neo4j, and use a cipher query, unwind statement, and here we merge a dream to a dreamer by the dreamt by relationship. Now we join similar dreams with the most similar relationship. Remember, with the similarity score above 0.6. So here I'm filtering. We have 62,000 similar pairs. So the dictionary looks like this is the source ID, dream ID, the target ID, and the similarity score. And here we go with the cipher statements, merging to the most similar dreams and setting as an edge property the similarity score. Loading our named entity nodes, same process. Create a dictionary, iterating through the rows, unwind, and merge. Connecting dreams and their entities with the has-entity relationship. Yes, it's starting to look familiar. Here with the has-entity. So a dream has an entity. So this is the resulting schema on Neo4j, right? Dreams are connected to other dreams by the most similar relationship. A dream is connected to a dreamer by a dreamt by relationship, and to an entity by the has-entity relationship. We end up with 43,000 nodes and 164,000 relationships. Probably what is the most interesting part of this talk is the text-to-image generation. And for this, we have to thank text artist Avid, who created the PyTorch model LF2 image delta and made it available as a Google Colab notebook, of which here is a screenshot. So Google Colab affords you a free GPU instance that you can run this PyTorch model, which is actually made up from combining two components of OpenAI, DALL-E and Clip. So it's super interesting, and you can give it a text prompt, which in our case was the first sentence of each dream, and run it, and it will generate those trippy images that we saw. So here is an example of an image. The first sentence that we fed to the model. I am reading about a new type of professional soccer league in a Color Weekly news magazine. Well, this image is definitely of a magazine. It's very colorful. There are soccer players and maybe even some Japanese characters. This one we saw in our visualization. I was in a football stadium with my daughter, Christina. I think it's quite interesting that it assumed that it was a man that took Christina, the daughter, to the football stadium. So, gender-wise. So this is, I think, my last slide. Here are some links to sign up to use GraphXR. You can find some instructions on how to create a GraphXR project and connect it to your local Neo4j instance. This is a link to our help desk area, so you can find answers to your questions and how to use GraphXR. And there's even more detailed instructions and more videos on our original blog post about how to process the dream data and generate the visualizations that we looked at. So yeah, thank you so much, everyone, and I hope you enjoy GraphXR. So that's all for you.